Hello everyone, welcome to Jivka Silkobio YouTube channel. If you have not subscribed this channel, then please subscribe. So in today's video, I am going to talk about ligand similarity research, which is used for ligand-based virtual screening. So um, let's start. So for ligand similarity search, there is a web tool available, okay, and this is SwissSimilarity, and this web tool is freely available. Anyone can use it. So in order to use this web tool, you need SMILES format of a Curie molecule. So Curie molecule is it can be a small molecule, okay, or it can be a natural product also. So you need a SMILES format of your Curie molecule. So if your SMILES format is not available, then you can draw the molecule using Sketcher. So here I'm going to draw the structure of paracetamol because structure is very simple, and let me draw it. So you need here OH group. So here simply you have to, so this one is acetyl group, and here you have to give NH. So this is the structure of paracetamol. Now you see the corresponding SMILES of paracetamol is available here, and now you can proceed. So in second option you see that that you have to select the class of compounds. So here I'm selecting drugs, and in third you have to select the library and the method, okay, screening method. So I'm going to select here drug bank, and the method is FP2, which is fingerprints, and FP2 fingerprint, and then the method is it is under 2D. You can also use 3D or combined, okay, 2D and 3D. We will see, okay. So first here, after selection of the compound library and screening method, now in fourth option you see you have to click on start screening button. So this will take less than 1 minute. Yeah, now results are available. So this is the structure of Curie molecule, and these are the run parameters, okay. And here you see, so the first result is always the same molecule, okay. So your Curie molecule is acetaminophen or paracetamol. So your first result is, if it is available in the library, then it's going to be your first hit, okay. So it has a score 1. It means it's identical to the Curie molecule. And here I see this is methacetine, dioxanide, and phenacetine. So phenacetine is also an analgesic, as well as it is also used as an antipyretic, okay. But I think now it has been like discontinued, okay. It was withdrawn from the Canadian market, okay. So now it is not in use. Let me check again whether phenacetine is in the market or not. It was used as an analgesic and fever reducing drug in both human and veterinary medicine for many years, but now it is not in use, okay. It was the first non-steroidal anti-inflammatory drug and fever reducer to go on the market, okay. But let's see. So you see, these are, so basically, if your Curie if any molecule which is highly similar to your Curie molecule will have the same biological property, okay. So paracetamol has analgesic and antipyretic properties. So any molecule which is very similar to paracetamol, you you can guess that okay, your that molecule will also have analgesic and antibiotic properties. Okay, but it's not always true, because what happens, the paracetamol, the exact mechanism of action is like it's not known. The exact drug target is not known. It generally it reduces prostaglandin synthesis. Okay, and in active site, even a small substitution in the ligand can have large impact. Okay, so maybe the active site can't uh, accommodate that molecule. Okay, so in that case, yeah, it is possible that even a small substitution can have different properties. Okay, so can uh, can uh, can actually affect your molecule. Okay, so let's see. So you see all this. So as you will scroll down, and you will see that these scores are decreasing now, and so it is better to always consider scores uh, above 0.85. So you can select up to here. Okay, or even 0.8. Okay, so but don't consider any molecule which is showing 0.7, 0.6, 0.5. Okay, so up to 0.8 is okay. So methacetine is highly similar, but this is not an analgesic. So you see, it is a radiopharmaceutical indicated as diagnostic agent in liver function test. So let me check here, methacetine. No, it's not. Actually, methacetine is, it can, so let me check. Okay, methacetine is subsequently metabolized into CO2 and paracetamol. So yeah, I think methacetine is not, uh, so it's not a painkiller. It's rather it's used uh, as a radiopharmaceutical but it is highly similar to paracetamol. Okay, you see. And what about this drug? So this is not also a painkiller. It's an protozoal drug used in the treatment of entamoeba. So see, it's a highly similar to paracetamol, but still it has different function. Okay, because of see the OH group. Here is acetyl. Here there are two chlorines. Okay, so maybe due to these two chlorines and one methyl group, here you see this substitutions are actually giving different property to uh, to to this drug. Okay, so if the two hydrogens will be substituted by two chlorines, and here the N, if you substitute the hydrogen on nitrogen by CS3, then what will happen? This is now an anti-protozoal drug. Okay, so think about the difference when you substitute a functional group or atom by different atom or functional group. Okay, now you can save these results. Okay, you can actually save these results in CSV format. So click on this. And now the screening results are available in CSV file. You can open the CSV file and you will see the smiles notation of all the molecules. Okay, and here this option is just for, you can send this to SwissSimilarity. You can also send this molecule to Swiss target prediction. So uh, about Swiss target prediction tool, I will talk about this tool in another video. Okay, so here I'm going to use now combined method. So let's see the results. So combined method will take some time. Okay, oh, it's very fast. So drug bank is very small database. That's why the screening is very fast. But if you will use Zinc, other database which is very large, yeah, you see the now results are little bit different. So phenacetin is Salmit. Let me check. It's for multiple myeloma. So you can get different results if you use different methods. Okay, but still the highly scored, highly similar compounds will be always in the uh, top 10. Okay, top 5. So top 10, top 5 or top 10. So you can check it. You can use different methods and you can see the differences. Okay. If I select here different database like Kimball, so suppose if I use here bioactive, okay, and here you see Kimball actives only, then let's check. Let me check this. So Kimball database is is a popular database which you can use for virtual screening also. So you see here, so Campbell 112 is itself a paracetamol or acetaminophen. So then again, this is, so you see. Okay, so in this way, you can use SwissSimilarity for ligand-based virtual screening. Okay, so this is called ligand-based virtual screening because what you are doing, you are entering smiles of a ligand, and then you are going to retrieve similar molecules. So it is generally the purpose is to screen molecules which will have same properties, same scaffold. Okay, but it is not necessary that uh, the molecules, if the scaffold is same and it will have same bioactive bio like it will have same function. Okay, so even the scaffold is same, it can have different property, it can have different properties. Okay, so thank you for watching this video.